tree. Okay, T stands for tree. Binary search tree. Now, something that is, something that's different between, something that's unique to a BST is the following. You have a binary tree, right? A binary tree. Then you get a binary search tree. Now, in a binary tree, the children are maximum 2, right? So you can see the children of this node is 0. It doesn't have any children, so it's 0. This tree has 2. Okay, so this is a binary tree. It can also have 1 child. So if I delete the 2 like that, then it's still a binary tree. Now the thing about the binary search tree is that one point very unique about the binary search tree is that you have your root, or your parent. It's also known as the root. Okay, it's not really your parent. This is the root. Root means the greatest, grandest parent. So this is the root, and it has children. Now in a binary search tree, numbers that are less than the root are always on the left side. Okay, and by numbers that are greater than the root are always on the right side. So if you have this parent, you also see that numbers less than that are on the left and numbers on the right are greater. So this is just something about the binary search tree that's unique. Okay, and another thing, when we're coding a binary search tree, we're going to have some algorithms inside of it. And let me just get you through one of them. One of them is an insertion algorithm. The other one is a find algorithm. There's a lot of algorithms you can apply on a BST. But one thing I want to tell you is that when you're coding a BST, okay, you see that this is called a node, right? And this is also a node. And this node is referencing a left and a right. This node is also referencing a left and a right. So is this node, left and right. So we're going to have, the way we're going to code it is like this. Like a doubly linked list node. Alright? This is going to be the right, this is going to be the left, and this is going to be the data. Okay, like 5 would be here, and the address for the 7 would be here, the address of the 3 would be here. This is just the basic principle, fundamental principle of coding a BST, if I tell you in short. Okay, so yeah, that's pretty much BSTs. And another thing about a BST that I really find important to tell you right now is that how to insert stuff into it. So assume I have some data. Okay, I'm gonna make this a 7. I'm gonna make this a 3. I'm gonna make this a 2. Okay, and maybe let's add some more. So now when you're inserting stuff into a BST, okay, I want to insert this. You're gonna start like this. Okay, 5 is our, no, let me do it in a different color, pink. Okay, so we have 5. 5 is inserted, right? 5 becomes our node. Then we have 7. So now once you insert, you're not going to put it 7 anywhere, alright? Remember, it has 2 children, but you're going to have to pay close attention to where you're adding the 7. Okay, 7 is greater than 5. So in a BST, greater numbers are always to the right. So 7 comes here. Okay, then you come 3 again. Now we have to insert 3. So you start at 5 again. You don't start at 7. You start at 5. You compare. Is 3 greater than or smaller than 5? Smaller than? Okay, so it comes on the left side. Done. Then we insert the 2. So you start here by the 5. Is it greater than or less than 2? It's smaller than. So we come to the 3. We go to the left side and then we end up by 3. Now is 2 greater than or less than 3? It's less than 3. So then we move to the left, because in a binary search tree you always move to the left. Now after that, another thing is oh yeah, we have the 1. So we check the 1 as well. So is 1 greater than or less? It's less. So we come to the 3. Now is it greater than or less than the 3? It's less than. So then we move to the 2. Is it greater than or less than the 2? It's less than. So to the left. So this is just how we insert stuff into a binary search tree, right? And yeah, that's something, you know, important. So if somebody asks you where the minimum value is, you'd know it's here, the leftmost value, and the maximum value in the tree is here. So next we're going to look at the algorithms, or before we look at the algorithms, we're going to code a binary search tree. We're going to translate this diagram inside into C++ language.